Hello and welcome to the Erste Digital Learning Day. Thank you very much for joining. In today's session, I will try to explain the journey that my team in payments in George went through building an effective testing strategy. I won't teach you how to write test code today, but a strategy how to ship software with confidence. Let's look at the polling result for the question, what slows development team the most? Most people voted that code is hard to test and therefore it slows the development team to move forward. And poor alignment between developers and testers is the second option here. All right, in my experience actually, that teams lose velocity because testing is an afterthought, not because of other criteria that we had in the poll. I will try to share experience why. Most front-end teams, whether web developers or testers or mobile, they chase feature delivery. And in general, it's a kind of cultural thing to make sure that shipping fast is the only KPI. Developers try to price the moments when the ticket is moved to the right to the testing column. And developers normally don't test. In general, developers don't like that. They want to build, deliver, ship, but testing maybe will be done by somebody else. Since we are separated, so developers pretend that the testing should be done by somebody else, they don't get feedback on the consequences from untestable code that they build, oftentimes. And when testing is done separately, means at the end, the developer tries to deliver and take the next ticket and takes the next ticket while the testers do the rest of the job. Here is a relative metaphoric picture where the dishes are washed afterwards. All right, the quality really suffers and the bugs start to appear, especially when you are already in evolved application that lasts for many years. And the implementation design has no chance to improve since the feedback is not received from how hard it is to test things and so forth. And developers just doesn't know that they do bad design that is hard to test. Everything becomes slower. Because after a sprint or after a release, depending when you start your next development circle, you first have to fix the bugs and only then you could work on feature delivery. Because developers build design, they don't get feedback about the design and therefore this design is hard to extend since testing oftentimes gives you a hint how to make the design also scalable. So testing and development, they impact each other. And writing tests also becomes really difficult within time. Because the test code, which is written by explicitly only testers and Q&As, is not in a shape where it could be if developers would review it at least. Therefore, this test code becomes cumbersome, hard to extend, hard to build new tests on top of the existing setup, and this slows the teams down. We lose efficiency, and what important is we lose motivation within time, within years. Developers disconnect from quality. This is somebody else's business, they think. The QA will catch, hopefully, the quality issues. The ping pong starts. So developer delivers a ticket, then switches the context to another ticket, to another task. Meanwhile, the tester tries to test the first task and then pokes the developer back that there is something more we forgot to implement. Developer should switch the context and implement again, pass the ticket back to tester. Hopefully tester doesn't find anything, but if found again, so the ping pong game continues. And everyone loses motivation because of many of these criteria that I mentioned. but the price for the company is very high for the slowing down. For example, let's say you would have such a chart where you would track bugs by sprint. And you see there are many 7, 8 bugs occurred after certain sprints. Let's say that your team needs to fix 8 bugs before starting working on the next sprint task. How long do you think it will take your team to fix 8 bugs? 3 or more days or 2 days? And now even if we look at this, if it takes, let's say, 2 days, then your sprint, at least my sprint, takes 2 weeks and means 10 working days. And if we take 2 days from that, it's actually 20% of time is spent on bugs. If we take that 8 bugs takes 3 days to fix, that's even more percentage of time is taken from the sprint to fix bugs. This is, I wanted to visualize for you that we are slowing down because the bugs are coming in after every sprint. And so we had this problem, exactly, that chart with the bugs is from my team. And it bothers us that we spend 20, 30, 40% at the beginning of the sprint to fix things from previous sprints. And only then we're able to continue working on the delivery. And we recognize that this is a problem and we wanted to fix it. I didn't introduce myself. I'm Nik. I work in George, payments, explicitly web. And I'm trying within these years to find ways how to make our work more efficient. I like software craftsmanship and making sure that I'm responsible for the quality as well. And in my free time, I train thousands of developers worldwide, normally through LinkedIn, because the teaching is also one of my passions. So we were exactly like everyone else. We were completely driven by features delivery. This was our main motivation, main goal. And testing was always last. Testing was done late at the moment where developer delivered the acceptance criteria in the ticket, in the task, then the testing started. And it continuously produces regressions. We received bugs from outside of the team that we were not able to catch ourselves. After every release, after every sprint, implementation design also suffered a lot. There was a year when I started in this company that the payment forms were demanded to take a code freeze for some months to fix the implementation design. That was an expensive turn for the company to stop delivery and fix the bad code that we had. But there was this time too. So we, spent a lot of time on fixing bugs. And the shift we made was that developers started to work together with Q&As. So literally together. Not that we are on one team and I'm responsible for building the features and then you are responsible for doing the Q&A. Not like that. We together were doing Q&A with testers. This within time made everybody in the team have an ownership of the quality of the output. That's everyone's responsibility. And then we came up to the point that we need some strategy to test so it's efficient. And it's important to understand what test. So we found out this testing pyramid and adjusted it to our needs. In our case, it's web, but this whole talk is for any front-end application. Could be mobile, iOS, Android, anything. And in this testing pyramid, let's start discussing it from the top. The manual and explanatory test is the most expensive test because it demands human. Human should click around, should try to find these unknown cases and so forth. But this gives the most confidence, right? Because the human completely replicates what the customer, real customer of our front-end app is actually doing. The second type of test in this pyramid is this end-to-end test, where you have to spin up the whole system, the environment with APIs, database, and whatever is demanded to run a test. This is also very expensive test. It's slow because it demands the whole system to run. It's flaky because the environment's unstable, and it's hard to arrange for each test a specific backend setup to run. Therefore, we thought that, okay, if it makes sense to use this type of test, then only for super critical user journeys. I would pretend that for a banking software, it could be authentication, because authentication flow is a critical for our apps, for our business. If it doesn't work, the whole application is redundant for a customer because it's not accessible. For all other cases, I would not do this test because of many reasons. Brittle, flaky, hard to maintain, hard to set up, slow. And we found out another layer of tests, that's integration tests, where in my team, we try to do most of the user journeys. But what is a user journey? I already mentioned the term twice. It's actually a task the customer of your app completes within your app. For example, in our banking setup, it could be creating an international payment. So the user journey is navigating to a payment form, filling in the data in the payment form, submitting that data, and then seeing some success state of the app. These all steps represent a user journey. So integration tests, we use them, and here is an example of an integration test. Test is the boundary of our app is stopped. Means that we don't go to the server, to the API, to the database to get a response, but we fabricate the boundary, how the API or database should respond back for a particular test. This gives a lot of control. And then afterwards, we try to write a code representing the user journey. So every step that the user does, for example, selecting a receiver for a payment as Dr. Watson, adding the amount of the payment and writing some purpose code or any other required data that is necessary for that payment, submitting the payment. And then we assert what happens on the boundary as well. So what is being submitted to the backend, that's important for us, and we assert this setup. This is an integration test. Here I'm showing an example for our React app using Cypress in components mode, but this is very possible to do using Playwright for web applications. And for mobile apps, a complete alternative for this is Appium. Probably people in mobile teams in George use this, or Maestro. So these are alternatives to write these full user journeys tests in different environments, different disciplines like mobile and web. And our team, before these integration tests were focused, we were writing integration tests using Cypress in different mode, where we had this Gherkin layer in front. Gherkin is this given when then scenarios written in English, so everybody could understand. And they had an intermediate between implementation of every line of the Gherkin scenario in the test code. So people initially believed that this gives and creates awareness around the software behavior for many people, not only technical people, not only testers, for example, but also business people who could read the scenarios and understand how the software is expected to behave. Kind of like living documentation. But you know what? I conducted a poll within business people, not technical people, within business analysts, within product owners, whether they use this, whether they ever read Gherkin scenarios we had in a code base to recall the expected behavior of certain features. And you know what? 1% of people told that they are even aware that we have Gherkin layer in place, even when then in English written scenarios. And this gave me a hint that we don't need this. We should throw this away. And therefore, in this integration layer, we decided that no, we won't do that. Who is a customer of these tests? We thought testers and developers are. These people will very quickly understand what happens by looking at such an example code like I show. All right, back to our pyramid. We decided that integration tests are for user journeys. But user journeys has a lot of deviations, a lot of edge cases that could happen. And these edge cases, if we put all of them in separate user journeys, then tests will take a lot of time to run because there will be a huge amount of tests. You do these variations and this and many other variations in a separate test. And remember, these are browser tests or app tests. They really boot the whole app to run. This is expensive. This is slow. This takes seconds to run. So similar way how a customer would interact with an application. Therefore, we should be careful. How do we split the behavior and how do we test these splits? All right. So we decided that all the deviations we won't put in integration test. User journeys will be happy paths, but different variations of the happy path will be on the business logic. So business logic, we wanted to test with unit tests, with the low-level tests. And what is business logic? Business logic are if statements, logical control structures, so meaning if conditions, logical branches, and so forth. Loops is business logic when you loop through something and then map something and so forth. Data transformation, for example, you extract from certain domain objects some nuances. This is also business logic, and side effects are business logic. So we in the team decided, okay, business logic will be tested using unit tests. That actually is the fastest test possible because it doesn't demand the app to be booted. It doesn't demand in iOS the whole app to be presented and run. Nothing like that. This will be just pure JavaScript functions, or in your language, in Swift or Kotlin, there for sure are some unit test frameworks like we have in JavaScript vtest or Jest. And there you will be able to do black box testing for independent functions. For instance, it could be a view model, something that is consumed by your view that will be displayed on the screen that needs to be arranged through some business logic. For instance, in certain criteria, you should return one value. In another criteria, you should return another value. So these type of tests are fast. This type of test could handle for us a certain level of behavior because we could get confidence from them too. But the confidence obviously is not so strong for business logic tests because they don't confirm that everything is wired together and works. These are separate units of the behavior and hopefully they work. All right. And after this, implementing this strategy and working together on writing high-level tests, we already started to see the gains. We started to see that regressions were going down, so we received less bugs from outside of the team. We found out that we had less surprises because the developers and testers started to sync very closely. We started to get predictable delivery. The code became cleaner since developers had a clear separation of concerns. They know, okay, business logic should be designed and built separately and tested separately. But the rest, the wiring code, this integration code, it will be tested through the user journeys indirectly. And we got the shared ownership of the quality since we were working together. This raised trust within the team. We started to trust each other very good because we are doing things together. And this also boosted the friendship. For me, explicitly, this is important because I'm always on remote with my team, more closely with people to see them on the camera. So I have a pair programming or pair testing every day with somebody from the team. This builds relationships. This builds friendship, not only work. So I tracked this for many years, the amount of escape bugs that our team receives from the moment when we started to adopt this pyramid testing strategy. To the last sprint, you see, there are some recordings, and the trend line demonstrates that we dropped from amount of bugs received from outside to almost 40%, okay, within these years. And what does it mean, 40% less bugs? For a team of 4 developers, let's say the average daily rate per developer in Vienna is 300 euros. So then the burn rate for 4 developers per day will be 1,200 euros. If we multiply these to 210 days, that's approximately the amount of days we work throughout the year. And then take a 40% from this amount of money, we get more than 100,000 euros saved with that. And same people, same product, we were building George payments on the web, but different habits, okay? And look, this is just one small team of 4 developers. How about how many teams in George we have? I went to Confluence org chat and calculated that there are more than 20 front-end teams, including web and mobile, iOS and Android. So just imagine the multiplier of savings it could be if everybody first had that problem that we had, and second, fix it this way. And why it worked? Because the quality became a routine for us, not a testing phase. That's a huge mindset switch. And now let's go to the blueprint. I will share you how explicitly to start applying the same thing that we did next Monday in your team. First important thing that we did is to measure the escape bugs, the bugs that pop up, and the bugs that are not caused by your team internally, let's say. They could come from different channels. I paired with my Scrum Master back then, many years ago, and the Scrum Master helped me to configure a filter in Jira or any other tool you use for development and tracking your work. Many escape bugs were popping up after every sprint. This is important to measure that because the impact, it doesn't lie. These numbers doesn't lie. The code coverage, it lies. But these kind of bugs that you get every sprint or every release, it's true information. And the quality becomes very visible for a team. So everybody is kind of very much aware of how well we went last sprint and before. And so you make people already sensitive to this. Okay, we know that we are good or we are bad. Okay, we failed last sprint, too many bugs arrived and so forth. This is good. And it's possible to configure in Jira very easily to have such a chart going on. The second step of the blueprint is to plan what to test and how. We do this planning right at the beginning of the sprint in my team. So whenever the plan for the sprint is done with the whole team, PO and business analysts, and we have our tickets already on the board, the first thing that we do, developers and testers, we open a mob planning session. Everybody participate and we review every ticket. And what we do in every ticket, we try to look at the acceptance criteria that business analysts prepared and identify where in this acceptance criteria is a user journey and where is business logic. So let's do a small exercise now. Here is a very simple feature that we will try to work on now. I give you 1 minute to read through that, and then we will reason about where is the user journey and where is the business logic. the timer is on. Feel free to read it. All right. So when I look at this acceptance criteria of this ticket, of this task, I see that there is a page to be desired, like in design, which will have some information to be displayed, like work interval and timestamp, and also some control or a button that will lead me to a separate page with some riddles, some quiz. And when I read these acceptance criteria, I see that, okay, this work interval that we are about to print, it has some logic. It depends on the current hour. Sometimes we'll print busy times, other times easy jets, and so forth. The formatting of the timestamp also needs some transformation from the date to a certain format familiar for traffic controllers in the airport. And I immediately say, okay, these are if conditions. I can look at that. I have experience. I'm a developer. I can say, okay, I will do something if the current hour is 5 or more, less than 11, then I should return a busy times, and so forth. The same for transformation of the timestamp. I will get some date instance that I need to format into certain string. This is business logic. And I'm already taking a decision, okay, I will write a unit for that and make a unit test low level on that. But then I think, but where is the user journey here? And the user journey is this. So the user actually navigates to this landing page or to this page, then clicks on the entry point, maybe sees that there is an interval displayed, work interval and timestamp. That's fine. And then after clicking on this button, the page should navigate to another page and the contents of this page should be displayed. That's the steps how the customer would interact with this. And that's the user journey identified from these business requirements, from these acceptance criteria. So we review the ticket with the testers, developers and testers together, and we write high-level notes directly in the ticket. Unit test, work interval calculation, timestamp formatting, integration test, and we capture the user journey. Open landing page, see interval timestamp, maybe welcome message, if it makes sense. Click on the button, see next page with the contents. This is very high level. We put that in. The next ticket is taken further. And ticket by ticket, all tickets that are in our sprint board, we do this. And then at some point, we will write the unit test for that. Developers will start implementing, for example, and they will come up to the unit test because this was a decision already by the development team to do the, let's say, interval evaluation on the unit level. So we know that we want to write a high-level test, integration test for each of the intervals. It will be handled on the unit level. Like here we see some assertions, we call some function, and then this function is supposed to bring us an output. At some point of the development, it could be upfront if the team practiced test-driven development, or it could be afterwards when the developer confirms that the implementation seems already done. We pair with testers to write an integration test to capture our user journey that we documented already on the ticket. Here is an example with Playwright for web application, but as I mentioned, for mobile, the same tooling is available, Appium and another framework to do similar stuff. So we capture every step. The user enters a page, then sees the interval without details. What is interval? Just that interval presence is there, timestamp, and then clicks on a button or a link. And then we assert that the page URL changed and the contents of the page is displayed and visible. So simple. This gives a lot of opportunities for everybody to learn the domain knowledge, to get the domain knowledge, to exchange the domain knowledge, and to discuss right away all the possible edge cases, use cases, So developers doesn't switch the context. Testers are there together. Everybody could provide feedback, claim that it's hard to test, so developer can review the code, why it's hard to test. And also, if some unknowns for developer occurred before, maybe tester had an opportunity right away to point that out because the tester noticed something that needs to be done additionally. So this is incorporated on the test level and in the journey or in the business logic. And hopefully at the end, the test will pass. And that will mean that we have completed a task. So we are writing high-level test together. It doesn't mean that we always should write a complete test together. Sometimes we just draft the scenario together. So we just do clicking. There will be a button we pretend, we write this in test, or there already is a button. So we try to exchange as much as possible the knowledge, but the finalization of the test code is fine to be done by the tester. So don't consider that we completely write it from the beginning to the end completely together. The purpose of this session, a pair testing session, is to make sure that we are aware of all possible scenarios that needs to be implemented, that needs to work, and document this high-level journey, and everybody is aware and on the same page what should happen. Since we now involve both developers and testers into writing test code, this is everybody's responsibility to review these pull requests. So we take care of test codes now, the whole team. It's not only a separate phase that the testers owns their code. Everybody in the team now owns the test code. This has an impact because developers could give feedback to testers if the code is not so good, not so flexible, if there could be some abstractions created, like, for example, builders for API stubs or something, and other best practices from the development that developers earned and learned throughout the years. Plus, the behavior is fully understood by everybody. This is very good. Ownership is there. Domain knowledge exchange is very actively going. Common understanding, predictability, and reducement of ping pong, since we think already while we write the test and we can solve the things right on that session. This was the third kind of step in the blueprint, to write things together, to write test code together. The fourth is the first step in the blueprint is to make sure that you have a CI pipeline, continuous integration pipeline, that runs on every pull request. If you have a small lab, that maybe makes sense to run all the tests, unit and integration, or even end-to-end if you have a few, on every pull request. So you get feedback if the change lists that you are about to merge broke something that was working before. But whenever your app grows, and in our case, 2 years after the app grows, that we cannot anymore run all the tests on pull request. If we run all the tests on pull request, it will take a lot of time to move forward with this pull request. Therefore, we run only a chunk of tests that is related to the change list within pull request. There is a build system that could analyze the dependencies graph from the change list to the tests, and it will tell us what tests to make sense to execute. And therefore, since we cannot execute all the tests throughout the pull request, but only a chunk of them, we also run the test at the night. Here, you could see the feedback is printed from the CI pipeline directly into our Slack channel with the amount of tests run, what happens, where something broke, and so forth. And this gives us an opportunity to work and fix things. This kind of pipeline gives you a lot of confidence because it's an evidence. Every pull request you push, if it has green tests and the CI run all of them, you're confident you don't broke the previously developed and existing software behavior. So it's not a hope anymore, not a bet, it's just evidence. And the feedback is quite fast, especially if you follow the testing pyramid, if you make sure that business logic is on the unit level, so you get very fast unit tests feedback on the CI pipeline. And if you broke some units with the code that you pushed, then it's time to fix it before everything will be merged. The fifth and the last step of the blueprint is fix, broken, test. So on the pull request, whenever you see your continuous integration task, inform that some tests were broken, like in this example. I have here some integration test broken, or could be unit test, whatever. My goal as a developer is to make sure that everything is green. And otherwise, I hopefully cannot even merge without having my tests run green. And in the night, if you cannot afford to run all the tests on every pull request, like we in George, we get nightly report. Important is that in the morning, whenever your team comes to the work, first human that appears online or in the office and sees something like this, a broken integration test here reported in the night, the investigation needs to be done the first thing. So you freeze feature delivery until you fix this. Why there is this? As you see, we are doing it proactively, super effective, like everybody interested in what happened, why it broke. Let's fix it, let's explore. And whenever you are done, that's green, you can continue with sprint delivery right away. This is a responsibility. This is a discipline. But this discipline has a huge impact. So you measure first, then plan testing together, testers and developers, then write tests together. Unit tests, no, I mean, developers will build that, but it's important that we talk about what will be on the unit level. So there is no miscommunication in the sense that we will try to write high-level tests now, duplicating what is tested on a low level on a unit test. So write user journeys, test together. This will help out with many benefits, and have a continuous integration pipeline that you could trust. When you have it, the ultimate goal is to make sure that you are green as soon as possible after the brokerage. Therefore, I put this step in the middle. And then you continue doing this loop, this blueprint 1, 2, 3, 4, 5, all together. Develop and continue planning and write tests, see whether you broke something, fixed it, make green, all in place. And actually what we looked at today is nothing new, really. It's practices from extreme programming. These were introduced more than 30 years ago. In the early 80s, we do whole team, we do customer test, means user journeys, we do collective code ownership, we do this planning, what to test, how to test, pair programming or pair testing or mob testing altogether, continuous integration with our pipelines. See, nothing new. And this blueprint works. I can guarantee you, we do this throughout the years. We mastered to follow this strategy, and we achieved a 40% bug reduction. I have shown you on the chart. This is a lot of savings for the company. And how do we use this? So 40% free time for us. Instead of fixing bug at the beginning of the sprint for 40%, we use it to build features faster. Yeah. So steal it, make it your team's routine, ship fast, and do it together.